So I'm going to do a quick example of how to change the range in your histograms in Jupyter Notebooks. So this is very similar to what you're going to be doing on the assignment today. All right, so here's, I just made a Jupyter Notebook like 10 minutes ago, but I haven't even titled it. But here, first thing I do, I really should have just put my name on here. Why do I never put my name on these? Whatever. Okay, so you import your libraries. This is going to bug me. Enrique. Science, fluid, physics, west side. Look at all the typos, and we'll move this to the top. Oh man, I hate when it does this. Here, I'll just clean this up. This is going to really bug me. Backslash, 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 backslash. There you go. West side. Notice it doesn't have my last name. Okay, whatever. Okay, so Enrique Physics West Side. This thing imports all the math libraries. I actually don't even need random and this kind of stuff, but whatever. I just put it. I cut and paste from somewhere else. Okay, so now I can plot things. That's great. I need to be able to read in the data. So yours is not going to be the penny mass data. Yours is going to be the 2 muon data, and you can just cut and paste what I put on Canvas, but it's like in my GitHub repository. Or you can just download it off the CERN website. So this is like open data. This is free data for everybody. They don't have that many CSV files. It's in this other weird stuff called root. But let's not talk about root too much. But anyway, this is the data sets down here. I picked the biggest one because it's got lots of data. But this was done in the video we watched today. It was like they were looking at 2 photons as the products. This is 2 muons, which are different kinds of leptons. But high five. So anyway, that's the data set you're going to use. I'm going to use penny mass data. Penny mass data, by the way, is, let me hit execute here. So the data is in there, right? If I hit data head, what does my data look like? Well, it's 150 rows by 2 columns. So let me just clean this up and just show the first like 5 rows. So I'll do parentheses 5 there. So so as you can see, it's like the year of the penny and the mass of the penny in grams. Okay, so like what this is a collection of is 150 pennies from different years. They're not all 1974, and they all have different masses. Cool. Let's make a histogram of the pennies, penny masses. So how would I do that? So I'm going to use this command, right? plt.hist, and then I want to like put my data in there, right? What's the data called? Well, the data in this case is called. It's from this data. This variable called data. Right, has a couple of different columns, year and mass. So I could do year or mass. I'm going to do mass. So how do the masses of the pennies look? Okay, and then if I just hit play, it's going to do the default number of bins, which is, I believe, 10 bins. So that's what my histogram looks like with 10 bins. So I can change number of bins on here by doing comma. Like I could do 2 bins, for example. What will that look like? Well, what is this saying? It's saying there's 40 pennies that have mass between 2.4 and 2.8. So there's 4, and then there's like 100 pennies between 2.8 and 3.2. So a total of 140 counts, or 150 pennies basically is what it was. So this is like actually a little more than 40. It's a little more than 100. Does that make sense? It's right there, 43. There's 43 pennies in this one, and there's 107 pennies in the other one. That's great for 2 bins, but that, what if I did 20 bins? So I just made that a 20, see? Now I'm going to hit execute. So this is kind of what you're doing. You're playing a game with the mass data, and you're trying to figure out the optimal number of bins that tell you. So this tells me a little bit more about the distribution. See, it says there's a lot of pennies over here, and there's a lot of pennies over here, right? There might be like a bump of pennies right there. So I'm kind of concerned with like zooming in, okay? Like I want to zoom in to over here and see what's over there. How do I do that? Because that's like what you're going to be doing. So I can change the number of bins, right? And maybe 20 is not good. Maybe I should do like, what happens if I do 2,000 bins? So first of all, 2,000 bins, this is actually interesting because there's only 150 data points, right? So what do you think 2,000 bins would look like? Oh my gosh, what's this? So notice that every bin that's visible has 1 or at most 2 counts. That makes sense, right? If I have 2,000 bins and I have 150 data points, most of them are all going to be in 1 bin. And this isn't going to tell me, like if I had 200,000, let's do 20,000. I want to get everything so it has one bit. I guess probably two of the numbers are the same, so you're not going to actually get all ones. But like you can get pretty much all ones. So you know, you can have too many bins in your histogram. Okay, let's go back to like let's do like 42 bins, because 42 is the answer to everything, right? 42 bins. Okay, so like I said, I want to zoom. Maybe I want to zoom into over here, right? I want to get some clarity. Maybe I say there's a bump over here that's some that. What's the number, right? Because I want to zoom in. So I'm interested between 3 and maybe 3.2, right? How do I change my range of what to display, right? Because I can't click on this. This doesn't like, it's not an interactive graph. So the way you do this is by putting comma range equal, and then you have to put it in brackets, and then you put in the low value, which in this case I'm going to say 3, comma, and then the high value, which is like 3.2, right? So if I hit play, notice it's remade my graph, and now I'm looking at, so I have 42 bins, but I'm only looking at the bins between 3 and 3.2, right? So I can actually like zoom in. I was like, oh, there's something maybe right here. So what I could even zoom into that. Like, how do I zoom into in here? So 3.05 to 3.09 or something like that. Like, so you can just go up here and change your range. 0.05 to 3.09. That's how you do. Oops, there's too many points in there, right? Let me get rid of that. Paranoia. So that's how you're gonna have to do this kind of thing, and then it's like, okay, you can kind of progressively zoom in more and more until you get some information. It's like, okay, this is an estimate for my penny mass. I have 7 penny masses with exactly this. Maybe that's what the penny mass should be. Okay, so you're going to be doing this except with particle physics masses, and looking for like some mysterious rabbit that always flips the die up at some, 3 point whatever it was. Once you have discovered, so like the last step of this activity, it's like, okay, let's say I discover some energy, so that you're going to be doing like penny mass, right? So the penny mass, let's say I found a particle at 3.08. Let's just, what is this? I can do better than that. 3.7076. So what you would do is Google particle with 3.076 GeV. Now GeV is the unit. So see that word right there, GeV? That's the unit. It's not kilograms. Now obviously these are pennies with mass of grams, right? But particles have GeV mass. It's like a made-up unit. There aren't many great matches. That's because there actually isn't a particle at 3.06 GeV. Okay, at 125 GeV, that's the Higgs boson, right? So if I had typed in 125 GeV, I get, look what would happen. Google would be like, Higgs boson, you found the Higgs boson. So it's actually discovered in 2012 by looking at photon decays. And so this is kind of like, what do I want you to turn in? So what I want you to turn in is the graph of your, maybe you should put in a couple of code block lines and show me a graph of your overall data, like the first one, and then the first histogram with like 10 bins or whatever, and then maybe you zoomed into one area you thought there was a bump, and you've identified the particle there, and then you need to turn in like some research that you've done on this particle. So, oh, I've discovered the Higgs. Peter Higgs discovered it in 2012 won the Nobel Prize with these guys like Peter Higgs and Engelbert and all that. God damn. You know why it's called the God particle? Because he actually, like, okay, so Leon Lindemann wrote the book. He talks about this, but the people who get to name the book is not the author. The author doesn't name the book. The publishing company is trying to sell books, and they like, so whoever published it, I don't know who published the God particle, but like published by which company? Dell. So Dell Publishing people are like, you want to name it what? No, we're not gonna. I mean, maybe this is the name he actually. I know the story of this, so I know this isn't like the actual name. So what he wanted to call it was the goddamn particle because it was so goddamn hard to find. So I don't know how the God. I mean, look at that book. I would buy that book if it was in a newsstand. The God particle, because particle physics, right? And they've discovered God, right? I'm going to at least read it. Have they discovered God? I don't actually know. So what he actually was trying to do with his title was saying how hard it was to build these things and discover this. This was super hard process of doing it. It has nothing to do with like religion, but the universe is the answer. What is the question, right? So you're gonna buy that book, right? It's interesting. Maybe it's religion in there. Look, a collision. Anyway, hey, hadron. Hadron means I don't know if you guys remember this. I said it in passing. It's either a meson or a baryon is a hadron. Hadron is like basically quarks. They smashed quarks together. So they did proton-proton collisions to do this. Protons are up-down quarks, and so they like smashed a bunch of quarks together. Why didn't they pick electrons? Lots of reasons, but like they're trying to do electron. Actually, one of the proposals in the future is to build a big accelerator that collides electron. I'm gonna go. I'm super late. I have to go. Okay, I'm gonna quit this video.